So let's get into our next concept, guys, which is measures of dispersion. So let's talk about the title of this topic first. Later, we can talk about what are measures of dispersion and who are measures of dispersion. So, dispersion. What is the regular meaning or the literal meaning of dispersion, guys? Disperse means go ahead, right? So, you can split, right? So, assemble means you can gather, disperse means you can split. So, dispersion. So, that's scatterness of observations. Got it, guys? So, if you want to disperse, means you can go whatever the way that you can go. So, means one observation might be here, the other observation might be here, the other observation might be here. Like this, observations got scattered. What is a measure of dispersion? You have to measure the amount of this deviation or scatterness or distance from your measure of central tendency. Let me repeat. You have to identify how your observations are moving far away from your measure of central tendency. But what is the use of this measure of dispersion? So guys, try to understand. This measure of dispersion will calculate, or it calculates the amount of deviation of your set of observations from any measure of central tendency. So guys, tell me, when do you say that a measure of central tendency is a good one? Yes, it is dependent upon all observations, right? It means the difference between the observations and a measure of central tendency should be least or highest. Least. The difference between your measure of central tendency and the observations will be calculated in a topic called measures of dispersion. Means what is the use of this measure of dispersion? This measure of dispersion will calculate the deviation of all the observations from their measure of central tendency. It means it is trying to verify the consistency of your measure of central tendency. Means whatever you have calculated in your measure of central tendency, whether it is good or not, will be explained by your measure of dispersion. Let me repeat, whether your measure of central tendency is dependent upon all observations or not, or whether it is dealing with everybody or not, whether it is at the middlemost place or not, all these things will be calculated or will be understood in a concept called measure of dispersion. Means measures of dispersion are trying to identify the exactness of your measure of central tendency. Let me repeat, they are going to explain whether your measure of central tendency is accurate or is exact or not, will be explained by a concept called measure of dispersion. So what are we going to calculate here? We are going to verify whether there is a deviation between your observation and average. Means you will calculate the difference between your observation and average. So guys, you will calculate the difference between all the observations and the average, no? So and then you will try to calculate the average of all these things. Means average of deviation from average. Let me repeat, average means sum of observations by number of observations. Deviation from average you will do. If this is least, that's a good measure of dispersion. Otherwise, that's not a good measure of dispersion. Means there are certain cases in which there are, let me assume that there are two students, guys, whose average is same. Average marks are same. Then I have to verify which average is more consistent. In such a case, I need to calculate measure of dispersion. After calculating measure of dispersion, if student A got less measure of dispersion and student B got more measure of dispersion, means student A got 10 as the measure of dispersion and student B got 11 as their measure of dispersion. Which student got less measure of dispersion? Student A. It means his average is more consistent than the other student average. That's what measures of dispersion are going to tell us. So here, these measures of dispersion have been classified into sorry guys, let's have a look at the overview of dispersion. There are two types of measures of dispersion. One is absolute measures of dispersion and the other one is relative measure of dispersion. Madam, what is this absolute measure of dispersion and what is this relative measure of dispersion? Just now I told you guys, we'll take an average and we just wanted to verify whether this average is correct or not. For that, we'll calculate the deviation of all the observations from the average and then we'll calculate the average of all these deviations. If this is done, the measure is called as absolute measure. And if that absolute measure is expressed as a percentage of average, that is called as relative measure. But what is the problem with absolute measure? Then why you are moving towards relative measure? Because absolute measures are meant for comparison only, right? But guys, remember, if you are having 10 rupees, 5 rupees, 8 rupees. So what is the average of 10, 5, 8? Let me calculate. 10 plus 5 plus 8, 23 by 3, and your average is 7.6 rupees, right? Now, if I ask you to tell me the deviations, 10 minus 7.6, I'll get rupees, no? Again, 5 rupees minus 7.6, I'll get rupees, no? 8 rupees minus 7.6, I'll get rupees, no? And then I'll divide it with 3, means my answer is in terms of rupees, no? Yes. If the first person absolute measure is 7 rupees and the second person absolute measure is 7 kgs, would you compare both? Can you? I can't, because both of them are different units. In ratio proportions, you have learned this concept. You are able to compare two items only if they're of similar kind. But one is expressed in terms of rupees and the other one is expressed in terms of kgs. How can you compare? That is the reason why you're going for relative measures, which are meant for comparison. So guys, absolute measure, let me assume that it is 7 rupees. What is your average? 7.6 rupees into 100. So this rupees will be cancelled, no? Yes, it means all the relative measures of dispersion are absolutely unit free and they are meant for comparison. So guys, whatever the absolute measures that we'll calculate here, we'll add a word called coefficient and we'll call them as the corresponding relative measures. Means what are your absolute measures? Let's have a look at them. Range, quartile deviation, mean deviation, standard deviation. Range coefficient, coefficient of range, quartile deviation, coefficient of quartile deviation, mean deviation, coefficient of mean deviation. Standard deviation has a different measure of dispersion, a different relative measure, guys, which is called as coefficient of variation. So what is a measure of dispersion? So guys, we have already talked about this. Look at this. The first important characteristic of a dispersion was given by central tendency, right? So now, two distributions may have same measure of central tendency, but they may differ in scatterness. So I have already told you, if two students got the same measure of central tendency, you will verify which measure of central tendency is correct by using dispersion. So to understand a set of observations, it is equally important to have a knowledge of dispersion, as dispersion indicates the volatility. Volatility means ups and downs, guys. So look at this, guys. All these three measures have the same measure of central tendency. All these three distributions or three graphs have the same measure of the central tendency. But if you look at the dispersion of first observation, first graph, this much of dispersion is there. Here, this much. Here, this much, which has more scatterness, guys. Third distribution. So it is more scatterness means less consistent. Got it, guys? So what is the use of calculating this volatility? Guys, suppose if you wanted to invest in a particular stock and that is more volatile, means there is no consistency for that. How do you invest? It has more risk, no? Yeah, those risk factors are also be understood with the help of this measure of dispersion. Got it, guys? So yes, we are here to calculate the dispersion, which indicates the variability of an observation from their average. Got it, guys? So how many measures of dispersion are there? So guys, we have two different types of dispersion. What are they? Absolute measures, relative measures. What are the absolute measures? Range, quartile deviation, mean deviation, standard deviation. So let's talk about relative measures of dispersion. The range corresponding relative measure is coefficient of range, quartile deviation, coefficient of quartile deviation, mean deviation, coefficient of mean deviation, standard deviation, coefficient of variation. So what is the difference between absolute and relative? Guys, tell me. Relative, to calculate relative measure, first of all, you need to calculate absolute measure. Means who are more difficult to compute, absolute or relative? Yes, relative, because as relative needs absolute, it has more calculations than absolute, right? So they are, who are difficult? Relative measures are difficult to compute, but absolute measures are easy to compute. Now, For comparing two or more distributions, we need absolute or relative? Yes, relative. So who are dependent upon units? Absolute measures are dependent upon units, but relative measures are unit free. Okay, so characteristics of an ideal measure of dispersion. So guys, these are copy pasted from characteristics of an ideal measure of central tendency. What are the characteristics of an ideal measure of central tendency? It is rigidly defined, easy to calculate, easy to understand. It should be based upon all observations, right? It should not be affected by extreme observations. It has higher sampling stability, means it must be least affected by sampling fluctuations, and it should have some desirable mathematical properties, and it is used for further algebraic treatment. All these things are the criteria came from the ideal measure of central tendency. Now let's talk about the first measure of dispersion. So the first absolute measure of dispersion is range. So what is the definition of range? For a given set of observations, range may be defined as the difference between largest observation and smallest observation. Guys, let me repeat. For a set of observations, range may be defined as the difference between whom and whom? Largest and smallest observation. It is the difference between largest and smallest observation. And the corresponding relative measure of dispersion is coefficient of range. And the formula for coefficient of range is L minus S by L plus S into 100. Here I just wanted to warn you one thing, guys. Sometimes he'll give you the value of coefficient of range in terms of percentage. But sometimes he'll give you the value in terms of decimals. Whenever you come across an option in which coefficients are in terms of decimals, means he is not taking this into 100 into the consideration. It is completely up to him, guys. We don't bother about that. We don't need to bother about that. So if your data or if your answer is in terms of more than 1 for coefficient of range, if your answer is more than 1 means it is into 100. But if your answer is like 0.55, 0.76 like that is there, means he's skipping or he's avoiding multiplying with 100. So what is the formula for range? Largest observation minus smallest observation. And the formula for coefficient of range is L minus S by L plus S. Guys, when it comes to discrete series and continuous series, I'll tell you who is largest and who is smallest while explaining MCQs. Now, the next important thing that you need to learn about range is affected due to change of scale. Range is unaffected due to change of origin. Because if my observations are 1, 2, 3, 4, 5, what is biggest observation? 5. Smallest observation? 1. Difference is how much? 4. Keep that. Keep in your mind that range is 4. Now let me add 10 to all the observations. 11, 12, 13, 14, 15. Guys, can you please tell me the range? 4 again. Means even if you add a fixed constant to all the observations, there's no change in the range. But if you multiply it with 10, 10, 20, 30, 40, 50, what is your range? Yes. How much? 40, right? So range is affected due to scale. But here I must tell you one thing, guys. Listen to me. If I multiply it with minus, so this one is a very important observation that you need to look at this. What is my biggest observation, guys? Take care of this. My largest observation is minus 10, guys. And my smallest observation is minus 50, guys. What is the formula for range? L minus S means minus 10 minus of minus 50. What is minus of minus 50? Plus 50. What is your answer? 40. Means even if you multiply your numbers with minus 10, your range is the multiple of plus 10. Means range is not only range, all the measures of dispersion are unaffected due to change of scale. Unaffected due to change of sign. They're just affected due to change of scale and they're not affected due to change of origin. Simply, if y equals to a plus bx, right? Range of y equals to, guys, tell me, what is the range of constant? 0. Because if all the observations are constant, what is your range? 0. So what is the arithmetic mean of constant? Constant itself, try to understand. So range of A is 0. And it is multiplied by b. I don't know whether b is positive or negative, but I am unaffected due to sign, no. That is the reason why I'll write mod b into range of x. What is it I'm writing? Mod b into range of x. For example, if you come across an equation like this, ax plus by plus c equal to 0. Guys, forget about all the signs. Simply write mod a into range of x is equals to mod b into range of y. Mod a into range of x is equals to mod b into range of y. So range is unaffected due to origin and sign, but it is affected due to scale. Of course, sign is also part of scale, guys, but I'm writing it particularly because you must understand this negative sign will not affect range, not only range. All the measures of central tendency, all the measures of dispersion are unaffected due to origin and sign, but they are affected due to scale. So means they are affected due to multiplication and division, but not even affected due to a sign. Try to understand. That is another important property of range. So guys, what is the formula for range? L minus S, and range is, so guys, now look at your range formula that is there in your textbook. So what is the meaning of range? For a given set of observations, range may be defined as the difference between largest and smallest observation. If L is the largest observation and S is the smallest observation, range equals to L minus S. And the corresponding relative measure of dispersion is L minus S by L plus S, which is also called as coefficient of range. Now I'll tell you what is a range when it comes to a discrete series and a continuous series. Let's get into MCQ part, guys. So guys, I'm taking some of the examples here from range and coefficient of range and their properties. So let me show you my first MCQ here. The first MCQ that I have taken is MCQ number 1. So guys, just be focused here. Following are the wages of how many workers? 8 workers expressed in rupees, means all these values are expressed in rupees. Try to understand. So what is the wage of first worker? 82 or 82 rupees? 82 rupees, try to understand. Next worker 96, next worker 52 rupees, next 75 rupees, next 70 rupees, next 65 rupees, next 50 rupees, and then next 70 rupees. Find the range and also its coefficient. Yes, tell me the formula for range. Range means largest observation minus smallest observation. Can you please observe what is your largest observation? I can see 96 as my largest observation, and I can see 50 as my smallest observation. So guys, what is your largest observation? Tell me. 96 or 96 rupees. 96 rupees, and my smallest observation is 50 rupees. Try to understand. What is the formula for range? L minus S. 96 minus 50 rupees. 96 rupees minus 50 rupees is what? Yes, 46 rupees. Got it, guys? So my range is 46 rupees. Now, what is the formula for coefficient of range? Tell me the formula for coefficient of range. Coefficient of range is equals to L minus S by L plus S into 100. All of you, tell me what is L minus S? 46 rupees. What is L plus S? 146 rupees, no? Into 100. Can I cancel rupees and rupees? And tell me what is 46 by 146 into 100? 31.51, guys. It means if you observe this, absolute measures are unit dependent, relative measures are unit free. Got it, guys? So that's how you can calculate the range. Now let's have a look at the next MCQ, and the correct option for this is option A only, right? So let's have a look at next MCQ. Next MCQ that I have chosen is MCQ number 5. The range of 10 observations is 20. If each item is divided by -2, then the range of new series is. So guys, let me assume that the old series is X. What is the range of X series? 20. So I'm writing range of X equals to 20. Range of X equals to 20. And each observation is divided by what? -2. Means it is given that Y equal to X by -2. Then tell me what is range of Y equal to? I've told you. Range of X by modulus of -2. What is modulus of minus 2? 2. And range of x 20. 20 by 2, your answer is 10. Guys, try to understand your answer is not minus 10. Your answer is plus 10. As it is unaffected due to sign, the correct answer is option B. Now, the next MCQ is MCQ number 8. Read out the MCQ. If the relation between x and y is given by 2x plus 3y equal to 10, then the range of y is 10. Then what is the range of x? So guys, what is the relation between x and y? 2x plus 3y equal to 10. So guys, simply I am writing the relation between x and y is 2x plus 3y minus 10 equal to 0. Guys, try to understand. Range is unaffected due to origin and it is not affected due to sign. It is just affected due to scale. That is why just write this way. Mod 2 into range of x is equals to mod 3 into range of y. Write it that way. Mod 2 into range of x is equals to mod 3 into range of y. What is range of y according to your question? 10. So means range of x is equals to 3 into 10 by 2, which is going to be 15, and that is there in option D. So try to understand the relation, guys. Whatever it is, write down the coefficient with modulus and write down the coefficient with modulus at the other side. That's how you can solve the MCQ. Now let me show you the next question. MCQ number 10. So guys, this is a very easy MCQ. So let's have a look at the MCQ first. So guys, look at the question. The frequency distribution of rows per plant on 50 plants in a garden as follows means there are 3 roses per a plant. How many such plants are there? 5 plants. Means 5 plants bloom 3 roses. That's what he's trying to convey. 8 plants bloom 4 roses. That's what his question is. Try to understand. So, find the range and its coefficient. Guys, tell me, we are talking about the frequency distribution of what? Roses per plant. That roses per plant is your x and the next one is your frequency. Range is not at all bothered about frequency, guys. So, listen to me. To calculate range, you must understand who is the biggest observation, means biggest x value. What is the biggest x value? 12. That is considered as L. And the smallest x value? 3. That is considered as S. Tell me the formula for range. L minus S, it means 12 minus 3. 12 minus 3 means how much? 9. Now, what is the formula for coefficient of range? L minus S by L plus S into 100. But guys, just now I told you, if your answer exceeds 1, he might have given you the answer in terms of into 100. Otherwise, he has given you the answer in terms of just L minus S by L plus S. What is L minus S, guys? 12 minus 3, 9. By L plus S, 12 plus 3, 15. What is 9 by 15 first? Tell me. 0.6 and that is there? No. Otherwise, the answer will be 9 and 60% because into 100, if you do into 100 means you'll get 60%. Guys, listen to me. You actually need to do into 100 and that option is not there, not even none is there. Then I have to verify that without into 100 whether I'm getting the answer or not. If you are getting, keep it as a correct answer. Okay guys, now let's have a look at MCQ number 11. So guys, look at this question. It's such an important question. You must understand the process of calculating range. What is the coefficient of range for the following distribution? So, how to calculate the coefficient of range? So, guys, coefficient of range formula is L minus S by L plus S into 100, right? So, who is L? Listen to me, guys. L is the upper class boundary of last class after the class has been arranged in ascending order. Are the classes arranged in ascending order? Yes. But if you look at the series, this is an inclusive series or exclusive series. This is an inclusive series. But I'm talking about boundaries, means my series must be exclusive. Madam, do we need to convert the entire series into exclusive? You don't need that, guys. So first of all, look at the difference between 20 and 19. How much? 1. D is 1. What is D by 2? 0.5. So to calculate the lower boundary, subtract 0.5. To calculate the upper boundary, add 0.5. Like that. What is the difference between 49 and 50? 1. Difference. 1. D by 2. 0.5. So to calculate the lower boundary, subtract 0.5, and to calculate the upper boundary, add 0.5. So I recommend you to do for the first class and last class only. Now, what is L? So guys, L means lower class boundary of first class. Which class? First class. So who is L? L is the lower class boundary of first class. S means, sorry guys, L is the upper class boundary of last class. L is the upper class boundary of largest value. No, sorry for it guys. L is the upper class boundary of last class. What is your last class? 49.5 to 59.5, and L is the upper class boundary. Yes. S is the lower class boundary of first class. What is your first class? 9.5 to 19.5, and this is yes. Now you have L and S, no? Calculate tell me the formula for coefficient of range. L minus S by L plus S into 100. Take your calculator and tell me what is 59.5 minus 9.5. Yes, 50 by L plus S. 59.5 plus 9.5. How much? 69. So your answer is 50 by 69 into 100, no? So 50 by 69 into 100. And your answer is 72.46, and that is there in option D. Guys, if you don't read out the question, most of the people will keep option B as the correct answer, as just they will calculate range, and the range is 50 only. So they will keep option B as the correct answer. So read out the question correctly. So we have to calculate the coefficient of range, but not the range. So guys, what is the formula for range? L minus S. Coefficient of range? L minus S by L plus S. Who is the L? Upper class boundary of last class? Yes. Lower class boundary of first class after the classes have been arranged in ascending or ascending order of magnitude, not in descending order even. So that's what you need to understand. Now, this is what about MCQs related to range, guys. Now, I'm directly moving into the theory because you are in such a position to understand the theory only after the completion of problems, guys. You must understand what is an extreme observation. You must understand what is a sampling stability and all. These things that you can learn only after the completion of MCQs related to problems, guys. Now, let's talk about the merits and drawbacks of range. Is range easy to compute or difficult to compute? Easy to compute. Of course, easy to understand also. So for a common man also, guys, verify the biggest observation or smallest observation means he'll do it in such a quick manner, no? Yes, but is it dependent upon all the observations or only few observations? Two observations. So the drawback advantage is it is easy to understand and easy to calculate. But the drawback is it is based upon only two observations. So guys, is it rigidly defined? Yes, as it is dependent upon a particular formula, it is rigidly defined. There is no doubt about it. Now guys, tell me, what is the formula for range? L minus S means biggest observation minus smallest observation. They are extremes? Yes, it means range is dependent upon extremes. So it will definitely be affected by extreme observations. Yes, range is highly affected by extreme observations as range itself is based upon extreme observations. And one more thing, for a continuous series, you are calculating the range based upon, based upon first class lower boundary and last class upper boundary. But for an open-ended classification, do we know the first class lower boundary and last class upper boundary? No. Means we can't calculate range, or a range is indeterminate for open-ended class interval. As for an open-ended class interval, we don't know the first class lower boundary and we don't know the last class upper boundary. Those two are essential to calculate range. So for open-ended classification, we can't calculate range. And one more thing is, I told you, what is the use of calculating these absolute measures and relative measures of dispersion? Yes, range, whatever the measure of dispersion it is, it must identify the exactness of average. Now, where is the average here? Who is the average here? So, if you are talking about a measure of dispersion is here. To calculate or to identify the exactness of average. Where is the average? Where is the measure of central tendency here, guys? Means we are not calculating any scatterness here. Means it is very indeterminate. We can't use it for practical purpose. The practical purpose of your dispersion topic is to understand or to identify whether your measure of central tendency perfect or not. We are not doing that. So it is very indeterminate, or sorry, indefinite, as it can't be used for any practical purpose. And one more thing, it is highly affected due to sampling fluctuations, guys. Now let's talk about the uses of range. So guys, might be you are aware of the word range chart. So guys, when it comes to any equipment or anything, you people will find tested OK as a symbol. Tested OK. You'll just find out tested OK symbol at anywhere on the product. Means I'm not talking about groceries and all, guys. I'm talking about, suppose whenever I'm talking about locks. So on that lock, at the bottom of that lock, you can see a small thing, a small sticker pasted like tested OK. So that testing is very much essential to control the quality of a product. So that is called as quality control department. That quality control department uses range chart to control their quality, to control their problems, or to control their mistakes, or else I can say to control their defective products. Yes, on a particular day or during particular 1 hour, they'll talk about the range of defectives, means least number of defectives and highest number of defectives through the production process. For every 1 hour, the production completes, let it be. So totally in a day, let us assume that 10 hours of operations is happening. So they'll identify the number of defective products during the first session, second session, 10th session, and they will calculate the range of defectives during that day. And they will present it by means of range charts by using day 1, day 2, day 3, and number of defectives on y-axis. So they will calculate range charts. So this range chart will give you a brief identification for the number of defectives. On a particular day, the range became this much. Range became this much. Means number of defectives got increased. No. It means there is a problem with that machine. If there is a problem with the machine, you have to adjust that machine, you have to correct that machine, you have to repair that machine, and then only you have to start the production. No. So in such quality control cases, in order to control the quality of a product, in order to give the better quality, so many quality control departments use range charts as their handouts. The next thing is to calculate the variation in money rates and of course share values. They'll present a chart that is called as range chart. Yes, of course, meteorological department will forecast weather based upon these range charts only. So the many uses for range, but it is not directly fulfilling its required purpose, as the requisite purpose of your measure of central tendency is to identify the exactness of average. That is not happening here. Now let's talk about the properties of range. So guys, you all know range is unaffected due to change of origin, but it is affected due to scale. Got it? And same property will be applicable for all the measures of dispersion. Yeah, now coming into the next concept called quartile deviation. So what is a quartile deviation? So guys, the word quartile deviation is also called as semi interquartile range. So guys, let's talk about the last word. What is your last word? Quartile range. Do you guys know what are quartiles? Yes, we know very well. How many quartiles will be there? 3 quartiles. What are they? Q1, Q2, Q3. Tell me guys, who is the highest quartile? Because the observations are arranged in ascending order, Q1 is the least number, Q2 is the middlemost number, Q2 is the biggest number. No. As the observations are arranged in ascending order, you must understand that Q1 is the smallest value, Q2 is the middle value, Q3 is the highest value. Now tell me guys, what is the meaning of range? Largest observation minus smallest observation. Who is the largest quartile? Q3. Who is smallest quartile? Q1. Tell me the quartile range. Q3 minus Q1. So quartile range or interquartile range means within quartiles range. What else is there? Semi. Semi means half. So this is called as quartile deviation. So let's talk about this. It is half of the difference between upper quartile and lower quartile. Now let's talk about the first point. This measure of dispersion is based upon upper quartile Q3 and lower quartile Q1. So the difference is the range between two quartiles, which is called as interquartile range, and half of this range is semi-interquartile range. That's why we'll call quartile deviation as semi-interquartile range. Now, what is a quartile deviation? Here I must tell you one thing, guys. If the distribution is symmetrical, second quartile or median equals to Q3 plus Q1 by 2 whenever the distribution is symmetrical. Now, the formula for coefficient of range is coefficient of quartile deviation equals to actually quartile deviation by median into 100. Tell me the formula for quartile deviation. Q3 minus Q1 by 2. Tell me the formula for median. Q3 plus Q1 by 2 into 100. Tell me guys, who are going to be cancelled? By 2, by 2. What else is left? Q3 minus Q1 by Q3 plus Q1 into 100. That is called a relative measure of dispersion, which is known as coefficient of quartile deviation. Got it, guys? So this is the introduction to quartile deviation, guys. Try to understand. Quartile deviation is an absolute measure. Coefficient of quartile deviation is a relative measure. So this relative measure is dependent upon quartile deviation by median into 100. Got it, guys? Now let's get into the MCQ part, guys. Means I'm talking about problems that are related to quartile deviation. Then only you are in such a position to understand the theory related to quartile deviation. Okay, so let's get into the MCQ part, guys. The first MCQ that I have taken here is MCQ number 12. So let me show you the MCQ, guys. Following are the marks of 10 students. 56 marks, 48 marks, 65, 35, 42, 75, 82, 60, 55, 50. Find the quartile deviation and also its coefficient. Guys, try to understand. It's not that easy. You have to be more attentive because if even one observation is missing, you have to recollect everything. So try to strike off the values that you have already written. So to calculate quartile deviation, we need Q1 and Q3. For that, data must be arranged in ascending order. Let's get into the order. The least observation here is, it seems, 35 and then 42 and then 48 and then 50. So let me write down the observations. 35, 42, 48, 50. Just a moment, guys. So I've told you 35, 42, 48 and 50. Let's talk about the remaining observations also. Next, 55, okay, 56, 60, let me write 55, 56, 60. Next, 65, 75, 82. 65, 75, 82. So how many members are here actually? 10 members. So what is n equals to? 10. Guys, let me write down the formula for Q1. Q1 equals to, I told you, 1 into n plus 1 by 4th term. Try to understand, 1 into n plus 1 by 4th term. So what is n? 10. 10 plus 1, 11. What is 11 by 4 equals to? 2.75 the term. So guys, I got 2.75 the term. Let me write the meaning of 2.75 term. I have already told you in central tendency, guys. It is second term plus 0.75 into third term minus second term. So guys, you need to take your calculators. Tell me what is your third term. 48 minus 42, how much? 6. This is 6. 6 into 0.75 plus, what is your second term? 42. What's your answer? 46.5. How much? 46.5. That's what Q1 is. Now, let me calculate Q3. So, what is Q3 equals to, guys? Q3 equals to 3 to n plus 1 by 4th term. As you already know, n plus 1 by 4th means 2.75. 2.75 into 3 is how much? Just a moment, guys. 2.75 into 3 is 8.25 term. So, 8.25 term, how do you write? 8th term plus 0.25 into 9th term minus 8th term. So, what is your 8th term? Take your calculator, sorry, 9th term. 75, no? 75 minus 65, how much? 10. 10 into 0.25, which is 2.5 plus 8th term. What is your 8th term? 65. Put together it is 67.5. So, we are just done with quartile calculation. There is something else to calculate. So, tell me the formula for quartile deviation, guys. Q3 minus Q1 by 2. Take your calculator. 67.5 minus 46.5 by 2. How much? 10.5. So, your quartile deviation is 10.5. That is there in option A. But option D, none. So, we need to do coefficient of quartile deviation also. What is the formula for coefficient of quartile deviation? Q3 minus Q1 by Q3 plus Q1 into 100. Madam, why you are writing into 100? Because all the coefficients are more than 1, no? So, I can use into 100. Now, let's calculate. 67.5 minus 46.5. What's your answer? 21 by 67.5 plus 46.5, which is 114. 21 by 114 into 100. Do that. It is 18.42 and that is there in option A. So guys, you must understand one thing. It's not that easy to calculate, but you have to do it in a systematic way. Then only the question will become easier one. Now let's talk about the next MCQ, guys. The next MCQ that I have taken here is MCQ number 18, guys. In the equation 4x plus 2y equal to 3, the quartile deviation for y is 3. Then find the quartile deviation of x. Guys, let me tell you, like range, quartile deviation is also unaffected due to origin and sign. It is just affected due to scale. So, simply write 4x plus 2y minus 3 equal to 0. Now, tell me the relation between their quartile deviations. Modulus 4 into quartile deviation of x equals to modulus 2 into quartile deviation of y. As the coefficient of x is 4, keep modulus. As the coefficient of y is 2, keep modulus in front of that. What is the quartile deviation of y? 3. Let it be 3. So, 2 into 3, 6. 6 by 4, 1.5. And the correct answer is option C. That's how you can calculate the quartile deviation based upon equation model, and this is called as this will be called as change of origin and scale criteria. Now let's have a look at MCQ number 19. The value of appropriate measure of dispersion for the following distribution of daily wages is given by. So guys, we have to calculate the appropriate measure of dispersion. So we have range, we have quartile deviation, that's what we have learned. So guys, tell me, is range is determinate or indeterminate for open-ended classes? As I can see, my question is of open-ended classes. I can't calculate range. So guys, tell me, quartile deviation is based upon whom and whom? Third quartile and first quartile. If you observe the data, this is your first quartile, this is your second quartile, this is your third quartile, which divides the data into 4 equal parts, no? Means 25%, 25%, 25%, 25%. If you look at Q1, it is after 25%, no? Or at 25th percent. Means the first 25% I am not bothered about it. If you look at Q3, I am not bothered about last 25% because it is at before that, no? Means this first 25 has first class and this last 25 has last class. So my quartile deviation is based upon this middlemost criteria. Means my quartile deviation is the best choice that I can go for on open-ended distribution. In case of open-ended classes, this fellow is the best because this fellow depends upon middle 50%. Open-ended classes lies at the starting or ending. This fellow exactly lies between the here and here only, right? Means this quartile deviation is taking account into how many observations? Only 50%. Means you must understand. This quartile deviation is based upon only 50%, means it is not based upon all the observations. Try to understand that it is not dependent upon all the observations. Got it, guys? So quartile deviation is dependent upon middle 50%, and it is don't have any problem with first 25 and last 25. Means it is the best choice for open-ended classification. So this is the best one. Next thing. Try to calculate quartiles. How to calculate quartile? To calculate quartiles, first of all, data must be arranged in ascending order or descending order. Let me write below 30. Below 30. Next 30 to 39. Next 40 to 49. Next 50 to 59. Just a moment, guys. 60 to 79 greater than or equal to 80. 60 to 79 greater than or equal to 80. Let me write down frequencies. What are my frequencies? 5, 7, 18, 32. 5, 7, 18, 32. And of course 28, 10. So this is my class interval and this is my frequency. Now let me go for LCF. So tell me 5 plus 7, 12, 12 plus 18, 30, 30 plus 32, 62, 62 plus 28, 90, 90 plus 10, 100. Means your total frequency is 100. Have to calculate Q1 or Q3. Q1 means the formula is, let me write down the formula. L plus N by 4 minus M by F into C. What is N, all of you? 100. Your N is 100. Now tell me what is N by 4? 25. Identify the class in which 25 was just exceeded in the less than cumulative frequency. 25 just exceeds 25. Yeah, this class. This is first quartile class. Okay. So L is the lower class boundary, guys. What is your lower class boundary? Is it 40 or 39.5? Yes, 39.5. N by 4. What is N by 4? 25. Minus M. M is the cumulative frequency of its preceding class. By F. F is the frequency of this class. Into C. C is the class length of this class. What is the class length of 40 to 49? It's actually 39.5 to 49.5. No, it is 10. Take your calculator. 25 minus 12 by into 10 by 18 plus 39.5. And your answer is 46.72. So your first quartile is 46.72. Now, let me calculate third quartile. What is the formula for third quartile? Q3 equals to L plus 3N by 4 minus M by F into C. What is your N? 100. 3N by 4 means 300 by 4. What is 300 by 4? 75. Now guys, could you please observe the cumulative frequency which was just exceeding 75? Yeah, this one. What is L? 59.5. 3N by 4, 75 minus M, preceding class cumulative frequency 62 by F, frequency of median class. Frequency of third quartile class into class length. Guys, try to understand. This is 59.5 to 79.5, which class length is 20. So 75 minus 62 into 20 by 28 plus 59.5. Put together, it is 68.78. How much it is? 68.78. Now, you know what is first quartile and you know what is third quartile. Tell me the formula for quartile deviation. 68.78 Q3 minus Q1 46.72 by 2, and the answer is 11.03. What is your answer? 11.03, and that is there with option B. So guys, 11.03, option A. So that's how you can calculate the quartile deviation. So now, let me tell you one thing. Quartile deviation is based upon how many observations, guys? All the observations? No, it is just based upon middle 50% of the observations. Try to understand. Means it is also not based upon all the observations. Okay. So, but it is the best measure for open-ended distribution. Now, one more thing. Who are extremes? Where do extremes lies? At the beginning or at the ending? But quartile deviation lies at the middlemost place. No. So, quartile deviation is not affected by extreme observations, as the first 25% we are leaving, last 25% we are leaving. No. So, now, is it based upon all the values? No. Next. Is it useful for further algebraic treatment? No, because as Q1 and Q3 are based upon position, they are not based upon all the values. Now, is it really showing the scatterness? What is the meaning of scatterness, guys? You have to calculate an average, and then you have to calculate the difference, and then you have to calculate the average. Any sort of that thing happened? Nothing. So means it is not showing any kind of scatterness around the average. It is just showing the difference between Q3 and Q1. It is showing the distance between Q3 and Q1. But in case of a high degree of variation, means if the deviation is so high, we can't calculate the perfect deviation. No. Then how do you use quartile deviation or even range? We can't do that. Next, you know that there is only one property for quartile deviation, which is quartile deviation is unaffected due to origin and sign, but it is affected due to only scale. So coming into the next important concept, which is mean deviation and coefficient of mean deviation. So guys, what is mean deviation? The name itself is saying, I'm writing the mean deviation definition, guys. The definition of mean deviation is mean of absolute deviations from any measure of central tendency. From any measure of central tendency. Let me underline, any measure of central tendency. It can be either mean or median or mode. Let me talk about mean deviation from mean. Mean deviation from mean is denoted by mean deviation from x bar, and that is equals to mean. Means sum of observations by number of observations. Mean of what? Absolute. Absolute means I'll keep modulus. Deviations from mean. Yeah, this is the formula for mean deviation from mean. Now, can you please tell me the formula for mean deviation from median? Summation modulus x minus median by n. Mean deviation from mode, summation modulus x minus mode by n. Guys, we'll not talk about mode, as mode is not based upon, as mode is not a good measure of central tendency. So in this concept also, we'll just tell you what is the meaning of mean deviation from mode, but these applications are not so considered, guys. They're completely ignored. Now, if it is discrete series, what is your formula? Summation f into modulus x minus x bar by capital N, the same formula. Summation f into modulus x minus median by capital N. If it is about mode, summation f into modulus x minus mode by capital N. These are the formulas for mean deviation from mean, mean deviation from median, mean deviation from mode. So what about coefficient of mean deviation? Coefficient of mean deviation from mean equals to mean deviation from mean by mean into 100. Now, can you guess the formula for coefficient of mean deviation from median? Mean deviation from median by median into 100. What is the formula for coefficient of mean deviation from mode? Mean deviation from mode by mode into 100. So, what is the formula? What is the definition of mean deviation, guys? Mean of absolute deviations from any measure of central tendency. Mean of absolute deviations from any measure of central tendency. So guys, range and quartile deviation are not based upon all observations, but mean deviation is a better measure as it is based upon all the observations. So I have provided you all the formulas that are related to mean deviation, guys. So this is what the introduction to mean deviation. Now let us get into the MCQ part that is related to mean deviation. Let us see the first MCQ that is related to mean deviation, guys. Look at MCQ number 23. So what is MCQ number 23? The mean deviation about mode for the numbers 4 by 11, 6 by 11, and of course 8 by 11, 9 by 11, 12 by 11, and 8 by 11. So guys, we have to calculate the mean deviation about, look at this, mean deviation about mode. How do you calculate mode and what is a mode? Mode is the highest focused observation, right? Or highest repeated term, right? Who is highly repeated term? What is highly repeated term? Tell me. Look at the data. Yes, 8 by 11 got repeated 2 times. Means your mode is 8 by 11. Now let me write down the formula for mean deviation from mode. Mean deviation from mode is summation modulus x minus mode by n. So what is n? How many observations are here? 1, 2, 3, 4, 5, 6. 6 observations are here. It means n equal to 6. Now we have to calculate the difference between the observation and the mode. What is 4 by 11 minus 8 by 11? It's actually minus 4 by 11, but there is a modulus symbol, so we have to take only 4 by 11. Okay. Next, 6 by 11 minus 8 by 11 is actually minus 2 by 11, but there is a modulus symbol, so I'm writing plus 2 by 11. Next, 8 by 11 minus 8 by 11, how much? 0. 9 by 11 minus 8 by 11 is 1 by 11. 12 by 11 minus 8 by 11 is 4 by 11. Next, 8 by 11 minus 8 by 11 is 0. Now tell me, what is your numerator? 4 plus 2, 6 plus 1, 7 plus 4, 11. What is 11 by 11? 1. So your answer is 1 by 6, means whatever the measure of central tendency that you need to calculate it first. And then simply use the formula called summation modulus x minus that measure of central tendency by number of observations. Got it, guys? So now let's have a look at the next MCQ. The next MCQ is MCQ number 25. If the mean deviation of the observations 1, 2, 3, 4, 5 and so on is 1.2, then the mean deviation of the observations 5, 10, 15, 20 and so on is what? Guys, if you look at the first set of data and second set of data, what kind of change is made to get the second set of data from the first set of data? Yes, first set of data is multiplied by 5 to get the second set of data. Let me assume that first set of data is represented by the series x. Okay, now tell me, what is mean deviation of x? Mean deviation of x is 1.2. Now we have to calculate the mean deviation of y series, which is a newly added series, and this series is obtained by multiplying x with what? 5. So y equals to 5x. So guys, unlike, like range, mean deviation is also affected due to only scale and not even sign. It means mean deviation y equals to modulus 5 into mean deviation x. What is mean deviation x? 1.2 into 5, because modulus 5 is 5 only, right? So what is 5 into 1.2? It is 6, guys. So that's how you can calculate mean deviation of the new series. Now let's have a look at MCQ number 27. If the two variables x and y are related by 2x plus 3y minus 7 equals to 0. So 2x plus 3y minus 7 equals to 0, and the mean and mean deviation about mean of x are 1 and 0.3. So mean is 1 and mean deviation is 0.3. Then the coefficient of mean deviation of y about mean is means mean deviation of y needs to be calculated. So guys, what is the relation between x and y? 2x plus 3y minus 7 equals to 0. So now I can write 2x bar plus 3y bar minus 7 equals to 0. What is x bar according to the question? 1, no? Let me replace x bar equals to 1. What is 2 into 1 bar? Sorry, 2 into 1, 2. 2 minus 7 is minus 5. If that minus 5 comes to the right side, it will be plus 5. Means 3y bar equals to 5, and hence y bar equals to how much, guys? 5 by 3. So I have calculated y bar, and then now I need to calculate the mean deviation of y. So guys, the relation between x and y is 2x plus 3y minus 7 equals to 0, no? Then you can write modulus 2 into mean deviation of x is equals to modulus 3 into mean deviation of y. So what is mean deviation of x according to the question? 0.3. So now tell me, what is 2 into 0.3? 0.6 by 3. It is how much? 0.2. So mean deviation of y equals to 0.2. So guys, tell me what is it you need to calculate? Coefficient of mean deviation of y. So tell me the formula for coefficient of mean deviation of y. Coefficient of mean deviation of y from its mean is mean deviation of y from its mean by y bar into 100. What is the mean deviation of y from its mean? 0.2 by 5 by 3 into 100. Guys, do one thing. If this 5 by 3 comes to numerator, it will be 3 by 5, no? So do one thing. 0.2 into 3 by 5 into 100. So how much? 12%. So what's your answer, guys? 12%. And that is there in option B. So it's all about understanding the relation between x and y. So and try to understand mean deviation is a measure of dispersion which is affected due to only scale. But mean is a measure of central tendency which is affected due to both change of origin and change of scale. Now guys, I'll tell you a very easy trick to identify mean deviation of a set of n observations when they are in AP. If the given set of observations are in AP, then the formula to calculate mean deviation is n square minus 1 by 4n into d. Let me repeat, n square minus 1 by 4n into d is the mean deviation of the observations which are in AP. In an AP, if there are n observations with common difference d, then the formula to calculate mean deviation is square root of, n square minus 1 by 4n into d. Got it, guys? So mean deviation equals to n square minus 1 by 4n into d when observations are in AP. Now let's have a look at the next MCQ, which is MCQ number 29. So calculate the mean deviation of the observations 10, 11, 12 and so on 30. So guys, here what is it you need to understand means how many observations are there? Yes, they are continuity, no, means they are in AP with a common difference of d equals to 1. So now guys, try to understand how many observations are there. So how to calculate the number of observations? Guys, from 11 to 30, how many observations are there? You can tell me. 20. And there is another observation which is 10. Together 21 observations. Or else, in your sequence series of mathematics, there is a formula to calculate the number of terms, which is number of terms n equals to last term minus first term by common difference plus 1. What is your last term? 30 minus first term 10. 30 minus 10. 20 by common difference 1. 20 by 1 is 20 plus 1. Together how many terms are there? 21 terms. It is completely up to you guys. So if you want to use that formula, you can. So now you said that n equals to 21, no? And what is your common difference? 1 only. So take your calculator. 21 square minus 1 by 4 by 21 into common difference is how much? 1. And I got the answer of 5.23. See how simple it is if you know the formula. So guys, you know, if he asked you to calculate the coefficient of mean deviation also, this is the formula to calculate the mean deviation from mean, guys. You need to understand that. So it's not mean deviation about median, or it's not about mean deviation about mode. This formula n square minus 1 by 4n into d is the mean deviation of n natural numbers which are in AP, or n observations which are in AP, which is nothing but mean deviation from mean. Now you know that what is the formula to calculate the arithmetic mean if the observations are in AP? First term plus last term by 2. If he asked you to calculate the coefficient of mean deviation, you can calculate mean deviation by using formula, and you can calculate mean from the formula. Got it? So now you can easily do that. Try to understand. Okay. So it's all about understanding the formula, guys. Now let's have a look at the next MCQ, which is MCQ number 34. Yeah, sorry guys. That's all about mean deviation related questions, guys. Now let us get into the theory concept that is related to mean deviation. Guys, I've already told you mean deviation can be calculated from how many measures of central tendency? 3 measures, no. One is mean deviation from mean, the other one is mean deviation from median, the next one is mean deviation from mode. In general, is mean equals to median equals to mode? No such restriction, means all these 3 measures are quite varying, no. That is the first drawback. If nothing is specified, what will you calculate? You need to calculate the mean deviation from mean only if nothing is specified. So guys, if we particularly said that you have to calculate mean deviation from median, everybody in the universe will get the same answer or different answer? Same answer only, right? It means it is rigidly defined by a particular formula. There's no doubt about it. But to calculate the mean deviation, we have to understand there is summation, there is modulus, and there are all deviations like that. Means if this average is in terms of fractions, every time if it is 2.578125, it's not that easy to calculate the difference, guys. You need to understand that. So means if your average is in terms of fractions, it is very difficult. It takes more time. Okay, sometimes there's a chance of getting error also, because we human beings makes errors. Definitely, it's a huge number means taking substitution also takes a lot of time, no? So in that hurry, instead of 2.52, if I write 2.25, I'll definitely get error. So means there is a problem, or there is a difficulty in calculating mean deviation if the average is in terms of fractions. And one thing, there's no chance of calculating combined mean deviation, so it is not suitable for further algebraic treatment. And one more thing, what is the uses of measures of dispersion, guys? To identify the accuracy of given measure of central tendency, right? We already know that mean deviation, mode is not a good measure of central tendency. What is the use of verifying the accuracy of mode here by using mean deviation? No use, no, because we already told to everyone that mode is not a good measure of central tendency compared to mean and median, right? Yeah, it is useful in many cases, but compared to mean and median, it is not so good, no. Then what is the use of verifying accuracy of mode here? It is a time waste task, no? Yeah, that is another thing. But let me tell you a very important thing. So I've told you that absolute measures means you have to take an average, and then you have to calculate the deviations, right? You have to take an average, and then you have to calculate the deviations, and then you have to calculate the sum of all of them, and then you have to calculate the average of all these fellows. All these things are being done here. Means it's completely satisfying the property of absolute measure. But there is a problem. So guys, let me assume that my average marks of a class is 50 marks. And one student got 45 marks. The other student got 55 marks. So if I'm calculating mean deviation, means I'll calculate 45 minus 50 modulus. What's my answer? 5. I'll calculate 50 minus 55 minus 50, and I'll calculate the average. No, it means for the person who got 45, you're getting a deviation of 5. For the person who is getting 55, who got 55, he's also getting the same deviation. Means we are giving the same preference to the person who got 45 marks in the exam and 55 marks in the exam. How is it accurate, guys? How is it suggested? Tell me. We are giving the same preference to plus 5 and minus 5. It means he is not discriminating plus 5 and minus 5. How is it possible? It's not so correct, no. It means mean deviation is so accurate at some point of view, but it is not taking the it is taking the modulus sign, no. Means there is a problem, So it's not such accurate, but it is accurate, or it is a better one compared to range and quartile deviation. And one more thing, if you want to reduce the effect of extreme observations, it is better to take mean deviation from median, because median is least affected by extreme observations, no? Yes, got it, guys? When it comes to mean deviation from mean, median, mode, all these measures are based upon all the observations, because you know that median is not dependent upon all observations, but after calculating median, you have to calculate the deviation from median, no? So here every observation is included. Now the next advantage of, or the next merit of a mean deviation is, compared to range and quartile deviation, this has least sampling fluctuations. Means it is more stable compared to range and quartile deviation. Got it, guys? So what are the properties? As I already told you, mean deviation will be least if the deviations are taken from median, because we have a property that sum of absolute deviations from median is minimum. So if you take the average as median, then mean deviation will be minimum compared to mean and mode. Next, mean deviation is unaffected due to origin, but it is affected due to scale. Okay, it's not even affected due to sign. And that is all about mean deviation. Coming into the very important measure of dispersion, which is standard deviation. So guys, I'll tell you the meaning of standard deviation. So guys, to overcome the drawbacks of range, quartile deviation, mean deviation, we are coming towards a measure of dispersion called standard deviation. So, standard deviation is denoted by the symbol sigma or S. If it is population standard deviation, we'll denote it with sigma, and if it is sample standard deviation, we'll denote it with S. As now we are calculating sample standard deviation only, we can denote it with S. What is standard deviation? For a set of observations, standard deviation may be defined as the square root of arithmetic mean of squares of deviations from arithmetic mean. So guys, let us write down the formula for standard deviation. Everybody look at this. Deviation from arithmetic mean means I have to write x minus x bar. Squares of deviation from arithmetic mean means x minus x bar whole square. Arithmetic mean of all these things. Arithmetic mean means sum of observations by number of observations. Square root of all these things. Yeah, this is what standard deviation is. Standard deviation equal to square root of summation x minus x bar whole square by n. Guys, try to understand the many formulas to calculate standard deviation. The first formula is summation x minus x bar whole square by n. This is one formula. And the next formula is square root of, same formula guys, after expansion it will be like this, summation x square by n minus x bar square. Do you know what is x bar? Yes, summation x by n. In case of continuous series, the formula will be square root of summation f into x minus x bar whole square by capital N, or else square root of summation fx square by capital N minus x bar square. Guys, what is x bar in the second case? Summation x by n? No, it is summation fx by n. The same formula will be used for continuous series where x represents the mid value of a class interval. So this is what the formula for standard deviation. Guys, let me tell you the drawback that is related to mean deviation. In mean deviation, we are calculating the deviations, but we are giving absolute symbol. That's a problem. That creates a problem, as it is giving the same importance to the person who got 45 and 55 that just now we have seen. That is the reason why instead of this modulus I am applying square and then applying square root. Means I am not avoiding any of the mathematical property. That is why standard deviation is a best measure, because the best measure of absolute measure of dispersion should be like this way. It has to talk about an average, deviations from average, average of deviations. Yeah, that's what we are doing. So it is going to satisfy all the properties that are related to absolute measure of dispersion. And one more thing I must tell you guys, if you know the merits and drawbacks of arithmetic mean, the same merits and drawbacks will be applicable for standard deviation as it is based upon arithmetic mean. So whatever the merits are there for arithmetic mean, they will all serve as merits of standard deviation. Whatever the merits are there for drawbacks are there for mean, they will serve as drawbacks for standard deviation, as standard deviation is completely dependent upon arithmetic mean. Now guys, you know what is a standard deviation. Now we have to talk about coefficient of standard deviation, no? So the formula for coefficient of standard deviation is standard deviation by mean only. Coefficient of standard deviation is standard deviation by mean, and the square of, sorry guys, s by x bar. If it is population means you have to write sigma. So guys, the square of standard deviation s square is said to be variance, and the corresponding relative measure of dispersion is called as coefficient of variation. The formula for coefficient of variation is s by x bar into 100. Means coefficient of standard deviation expressed in terms of percentages is called as coefficient of variation. What is the use of coefficient of variation? Whenever you want to compare the variability of two or more series, this is the best one. Coefficient of variation is the best one. So look at your theory part guys. So I have already covered these points. The best measure of dispersion is standard deviation, as It is overcoming all the drawbacks that are there for mean deviation, quartile deviation and range. And it is based upon all the observations. No. So the idea of standard deviation was first presented by Carl Pearson in the year 1893. And I have told you the meaning of that, and I gave you the formulas of all these things, guys. Now, if you look at the merits, guys, you can easily tell, because I've already told you the merits of standard deviation are nothing but the merits of arithmetic mean. So what is the first merit? It is based upon all those observations. It is rigidly defined. It has greater mathematical significance, and it is capable of further algebraic treatment. I'll tell you why, guys. There's the formula to calculate the combined standard deviation. Madam, what is the formula to calculate the combined standard deviation? S12 equals to square root of n1 into s1 square plus d1 square plus n2 into s2 square plus d2 square by n1 plus n2. So what is n1? Number of observations in the first set. What is s1? Yes, standard deviation of first set. Now what is d1? So guys, you know that what is x bar 1, 2? Yeah, x bar 1, 2 is the combined arithmetic mean, no? D1 is the difference between x bar 1 and x bar 1, 2. Got it? Difference between first set arithmetic mean and the combined average. And D2 is the difference between x2 bar and x12 bar. And what is x12 bar? Tell me the meaning of x12 bar. X12 bar equals to n1 x1 bar plus n2 x2 bar by n1 plus n2. Got it, guys? So that is what x bar 1, 2. Okay. So this is how you can calculate combined standard deviation. So I can say that it is capable of further algebraic treatment. As you all know, arithmetic mean is least affected by sampling fluctuations. The same thing is there. To compare variability, just now I told you, to compare variability, coefficient of variation is the best measure. No. Next, as it is based upon arithmetic mean, it has all the good qualities of arithmetic mean. That's what I'm telling you. Next, by using standard deviation, if you want, you can calculate the sum of squares of numbers. A summation x square also can be calculated. Okay. Got it, guys? So, but what are the drawbacks? It is very difficult to compute, guys, because it is based upon squares and square roots. No. So, that's why it is not easy to understand, and it is very difficult to calculate. Though it is very difficult to calculate, it is based upon all observations and it satisfies all the properties. No. So, we have to do that. There is no other option. And one more thing, you know that square root means it gives more weightage to extreme values. Got it, guys? Next, it consumes more time. And tell me, standard deviation is an absolute measure or relative measure? Absolute measure. Can it compare two series directly? No, it can't. So, if you want to compare two series, we have to approach coefficient of standard deviation or coefficient of variation. What are the uses of standard deviation? So, it is very much helpful in fitting a normal curve. In fitting a normal curve, mean and standard deviation plays a very important role. It is very much used in biological studies. For example, guys, so if you come across any blood test, they'll collect a sample, no? So, and they'll provide the information regarding your entire body blood samples. So, how is it possible? So, they'll just collect a sample, no? And they'll confine that study to population, no? There's a chance of getting error, no? So, yes, there always exists a deviation, no? So, means they will get some certain average. And they will provide you the limits based upon, if they got certain average, average minus standard deviation is the lower limit, average minus average plus standard deviation is the upper limit. When you come across blood test reports, they'll get you the range of original values, ranges from this one to this one. They'll just calculate the average and they will calculate the deviation and they'll verify the range. So, it is very much used in biological studies, guys. So, it also helpful for, guys, here we are calculating the deviations from where? Arithmetic mean means here we are trying to verify the consistency of arithmetic mean, right? So, what is the major purpose of our dispersion, guys? To understand or to verify whether the measure of central tendency is calculated by me in measures of central tendency was calculated by me is correct or not, right? So, for that, we are using measures of dispersion. So, here we are verifying the deviations from where? Arithmetic mean means in this topic, we are, in this concept called standard deviation, we are trying to verify the consistency of arithmetic mean. Got it, guys? So, unlike, like all the measures of previous measures of dispersion, standard deviation is also unaffected due to origin, but it is affected by scale. All the measures of dispersion computed for a constant is 0. You all know. Got it, guys? So, standard deviation should be more or less for the betterment, or if an average is good, means standard deviation should be less, deviation should be always less. So, a series with less standard deviation is said to be more uniform or more consistent. That's what the first property that is given to you, and I've already gave you the formula for combined standard deviation, and I told you about coefficient of variation. So, guys, tell me, coefficient of variation is an absolute measure or relative measure? Relative measure. What is the formula for coefficient of variation? Standard deviation by arithmetic mean into 100. So, coefficient of variation is nothing but coefficient of standard deviation expressed as a percentage of, is called as coefficient of variation, right? So, yes, coefficient of variation is the best one to compare two or more series, right? So, whenever you are given with two or more series, which series average that you can say is the best average? The series that is having lesser coefficient of variation is going to be the best measure of the central tendency, or it is considered to be a best series. Got it, guys? Now, what is the relation between quartile deviation, mean deviation, and standard deviation? So, guys, for a normal distribution, for a normal or symmetrical or moderately skewed, means a little bit of skewness is there, then there is a relation between standard deviation, mean deviation, and quartile deviation, which is 4SD equals to 5MD equal to 6QD. It means, what is QD, guys? QD equals to 4 by 6 into SD, which means 2 by 3 into SD. What is MD, guys? MD equals to 4 by 5 into standard deviation. Therefore, what is the ratio between quartile deviation, mean deviation, and standard deviation? 10 is to 12 is to 15. Guys, here you must understand one thing. Which one is having least coefficient? Standard deviation, means standard deviation is always bigger one. Next, mean deviation is bigger one, and the next quartile deviation is bigger one. So, who is the smallest one here? Quartile deviation. So, that's why he gave you quartile deviation is less than, mean deviation is less than standard deviation. So, difference between different measures of dispersion. As you all know, range is easy. Mean deviation is also easy, but compared to range, it is difficult. Quartile deviation is also easy, but quartile deviation is based upon how many observations? 50%. Range is based upon only 2 observations. Mean deviation is based upon all observations. Standard deviation is based upon all observations. But why mean deviation is ignored? Because there is a symbol called modulus. That is what the problem. So, otherwise, mean deviation is also better one. But who is easy to compute? Range. Who is difficult to compute? Standard deviation. Who is not affected by extreme observations? Quartile deviation. Got it, guys? Who is not affected by extreme observations? Quartile deviation, because it is based upon only 50%. Who is the most useful measure or the best measure of dispersion? Standard deviation. So, guys, I've already explained this concept in central tendency only, guys. So, this is whenever the distribution is symmetrical, mean equal to median equal to mode. Whenever the distribution is positively skewed. So, left side there is mode because it is highest frequency. Median will always be there. As mean is affected by extreme observations, mean turns towards right. So, now when it comes to this distribution, it is negatively skewed distribution. It is highest frequency, that is called as mode. Median always lies at the middle. And of course, so, as the distribution is negatively skewed, yes, extreme observations are at the left side. So, mean will always be at left side. So, how do you measure skewness? So, guys, there is a measure to there are certain measures to calculate the coefficient of skewness. What are they? So, guys, the first formula was Karl Pearson's coefficient of skewness, which is based upon mean, median, and mode and standard deviation. The formula for Karl Pearson coefficient of skewness is, look at this formula, guys, mean minus mode by standard deviation. As you all know that the distance between mean and mode is 3 times the distance between mean and median. That's why I have written this formula. So, there is another formula which is based upon quartiles, which is also known as Bowley's coefficient of skewness or quartile coefficient of skewness. What is Bowley's coefficient of skewness or quartile coefficient of skewness is? So, guys, forget about this. Just simply write Q3 minus 2 Q2 plus 1 Q1 by Q3 minus Q1. Got it? So like that, skewness can be based upon deciles percentiles also. So P10 plus P90 minus 2m by P90 minus P10, or based upon deciles D1 plus D9 minus 2 median. 2 median means D5 guys, by D9 minus D1. So where m equals to median, D5 or P50 also. So both of them are same. Of course, here we have 2 Q2 no. Who is Q2? Median only. So the same formula guys. First quartile plus last quartile minus 2 into median. Got it guys? So that's how you can calculate the measure of skewness also. Now coming into the problematic part guys. So we have seen what is measure of dispersion and how can you calculate measures of dispersion. Now coming into problematic part, let us get into the first MCQ guys. The first MCQ here is MCQ number 34 guys. Look at MCQ number 34. What is the question? The standard deviation of 10, 16, 10, 16, 10, 10, 16, 16. Guys, look at the data first. How many observations has been repeatedly coming here? 2 observations. What are they? One is 10 and the other one is 16. Tell me guys, 10 is repeated for how many times? 2 times. No? 10 is repeated for 1, 2, 3, 4 times. And 16 is also repeated for how many times? 4 times. Guys, here I must tell you a very important point. Whenever all the observations have same frequency, means all the observations are equally important. Means I have to take simple arithmetic mean or weighted arithmetic mean. Simple, if all the observations has given equal preference, I have to go for simple arithmetic means. See, in such a case, frequencies can be eliminated because all the observations were given equal importance. I can simply go for simple average or simple measure of dispersion, not only arithmetic mean guys. So you can ignore frequencies whenever the frequencies are same. Now tell me guys, how many observations are there? 2. So for 2 observations, you can use the regular formula of standard deviation summation x square by n minus x bar square, or else for 2 observations there is a shortcut to calculate standard deviation guys, which is half of range. Half of what? Range. What are the observations here? 10 and 16. What is your range? 6 by 2. What is 6 by 2? 3, right? And your answer is option C. So guys, people will tell the formula like this: half mod A minus B. The standard deviation of A and B is half mod A minus B. It's up to you. That is what about MCQ number 34. Now let's have a look at the next MCQ. MCQ number 37. The mean and variance of 5 observations are 4.8 and 6.16. Mean is 4.8, variance is 6.16, and there are how many observations? 5 observations. If 3 of the observations are 2, 3 and 6, what are the remaining observations? Guys, for this question, people will take the remaining observations are A and B, and mean is 2 plus 3 plus 6 plus A plus B by 5 equals 2. This much. They will do all those things. I'm not doing that, guys. I have to identify the remaining 2 observations. I'm going through option verification. Let me assume that option A is the correct answer. It means my remaining 2 observations are 4 and 9. Means what are my observations? 2, 3, 6 are given, and according to option A, they are 4 and 9. Now it's your turn to calculate the arithmetic mean of 2, 3, 6, 4, 9. Faster. What is the arithmetic mean of 2, 3, 6, 4, 9? All of them added and then divided by 5. I got this much, 4.8. So arithmetic mean is 4.8. That is verified. Now I have to calculate the variance too. What is the formula for variance? Let me write down this formula. Summation x square by n minus x bar square. Guys, let us directly do this with the help of our calculator. Summation x square. 2 square. How much? 4. Next 3 square. 9. Next 6 square, 36. Next 4 square, 16. Next 9 square, 81. So what is summation x square? 146 divided by what is n? 5. 146 by 5, which is 29.2. M plus, do m plus. Next x bar. What is x bar? 4.8. No, I need x bar whole square. 4.8 whole square, this much. M minus. Okay, now MRC. What I got? 6.16. That is completely verified. No, means you need not take relate the two observations are A and B. Arithmetic mean is 2 plus 3 plus 6 plus A plus B by 5 equals to 4.8, and then you need not write any equation, guys. There's a chance of option verification, whether it is in mathematics or statistics. This is the easiest way, guys. Now let's have a look at next MCQ. MCQ number 43. It is given that the mean of 10 mean is 10 and standard deviation is 3.2. Mean is 10 and standard deviation is 3.2. If the observations are increased by 4, means, guys, so mean of X series is given to you. What is the mean of X series? Just a moment, guys. X bar equals to 10 and standard deviation equals to 3.2. Means standard deviation of X equals to 3.2. There is a new series that is obtained by adding 4. Means Y equals to X plus 4. Guys, can you please tell me what is Y bar? X bar plus 4 means how much? Yes, 14. But it is change of origin or scale? Origin. Is standard deviation is affected? Not so. Means standard deviation of Y equals to 3.2. Or else if you want to go through formula, modulus 1 into standard deviation of Y equals to modulus 1 into standard deviation of X, as the coefficients are 1 and 1 only, right? Now let's see what is our question. I haven't completed reading the question. Then the new mean and standard deviation. What is the new mean? 14. And new standard deviation? 3.2. That's how you can solve the MCQ, guys. It's a direct question. Now let's have a look at the next MCQ. MCQ number 46. So if X and Y are perfectly related by 2X plus 3Y plus 4 equals to 0. And the standard deviation of X is 9. What is the standard deviation of Y? So simple logic, guys. Keep modulus 2 into standard deviation of X equals to modulus 3 into standard deviation of Y. Either you can write sigma X or Sx. No problem. What is the standard deviation of X? 9. So you can write 2 into 9 equals to 3 into sigma Y or Sy. It's up to you. So 2 into 9, 18 by 3, which is going to be 6. And that is the correct answer. Now let's go for the next MCQ. Before that, I must tell you another important formula, guys. If the observations are in AP, what is the formula to calculate mean deviation? N square minus 1 by 4n into D, like that. If the observations are in AP, standard deviation equals to square root of n square minus 1 by 12 into D. If the observations are in AP, this is the formula to calculate standard deviation. Now tell me, what is the standard deviation of first n natural numbers? Common difference is 1, no. So you can write n square minus 1 by 12 square root of. What is the variance? Just n square minus 1 by 12. So that's how you can solve the MCQs whenever the given set of observations are in AP. Now let's have a look at the next MCQ, which is MCQ number 54. Yeah. This is a very important MCQ, guys. For a group of 60 boy students, the mean and standard deviation of statistics marks were 45 and 2 respectively. Means the count of boys is 60 and the mean is 45, standard deviation is 2. The same figures for a group of 40 girls, means strength of girls is 40 and the mean are 55 and standard deviation is 3. What is the mean and standard deviation of the marks of two groups pooled together? Means we have to calculate the combined mean and combined standard deviation. For that, let me write down what are N1, N2 and what are sigma 1, sigma 2. Sorry, S1, S2 and what are X1 bar, X2 bar. N1, 60 members. N2, 40 members. What is the arithmetic mean? So X1 bar is given, X2 bar is given, S1 is given, S2 is given. Let us write down their means and standard deviations. Means 45 and 40, standard deviations 2 and 3. So guys, tell me the formula for X bar 1, 2. You all know N1 X1 bar plus N2 X2 bar by N1 plus N2. Except formula, I don't recommend you to write anything on the paper. Take your calculator. N1 60 into 45 M plus 60 into 45 M plus 2700. Next 40 into 40 M plus 1600. M plus MRC. What's your answer? Just a moment, guys. 4300. By what is N1 plus N2? Yes, 100, no? By 100. What's your answer? 40. Just a moment, guys. By mistake, I took a, sorry guys, 55 is the arithmetic mean. Sorry guys, by mistake, I took it as, yeah. Please do calculate it again. 60 into 45 M plus and 40 into 55 M plus MRC, yes, by 100. Sorry for it, guys. And it is 49. So combined arithmetic mean is 49. Now, there is a formula for combined standard deviation. Before that, let me write down the meaning of D1 and D2. D1 equals to x1 bar minus x12 bar. D2 equals to x2 bar minus x12 bar. What is D1? x1 bar minus x12 bar means 45 minus 49, which is minus 4. D2 means x2 bar minus x12 bar, which is 55 minus 49, and that is equals to 6. Now, let me write down the formula for combined standard deviation. So, sigma 12 equals to square root of n1 into s1 square plus d1 square plus n2 into s2 square plus d2 square by n1 plus n2. So, guys, I'll tell you how to do this with the help of your calculator directly. Let's get started, guys. Clear your calculator's memory first. S1 square, how much? 4. D1 square, 16. So, 16 plus 4, 20 into 60. 20 into 60 m plus 1200. Now, S2 square, 9. D2 square, 36. So, tell me what is 36 plus 9? 45 into N2. What is N2? 40. Again M plus MRC. I got 3000 by N1 plus N2. By what is N1 plus N2? 100. And I got 30. And I have to apply square root. After applying square root, what is it my answer? 5.477, which is approximately taken as 5.48. And that is there in your options now. See, it's all about writing the solution in the shortest possible way. So if you use your calculator, the solution will be quite easier, guys. Got it, guys? So that's how you can solve the MCQs related to standard deviation. Now let's get into the next question. MCQ number 55. The standard deviation for the following distribution is, guys, people will take change of origin scale method. So, but I don't take, guys. I'll simply write the mid values. What are the mid values? Here 51, here 53, here 55, here 57, here 59, right? So, now calculate the arithmetic mean. First of all, calculate the sum of observation, sum of frequencies. 17 plus 35 plus 28 plus 15 plus 5. How much? Total frequency is 100. So, guys, standard deviation is unaffected due to origin, no? So, if you want to do that, just simply subtract 51 or 55 from all the data. What is 51 minus 55, guys? Means I'm writing D equal to x minus 55. There's no restriction that you have to take 55. If you want, you can take 51 or 52, whatever it is. But I'm taking the middlemost value. What is 55 minus 55? 0. 57 minus 55, 2. 59 minus 55, how much? Yes, 4. So, 53 minus 55, how much? Minus 2. Here, minus 4. Okay, these are D values. So, I know that standard deviation of D equals to standard deviation of X. So, I am calculating the standard deviation of D. What is the formula for standard deviation of D? Summation FD square by capital N minus D bar square under root. Now, let me calculate D bar first. What is D? How do you calculate D bar? Summation D by N, summation FD by N. So, 17 into 4M minus 35 into 2M minus, so 28 into 0 is 0, 15 into 2M plus, so 4 into 5M plus MRC, which is minus 88 I got by 100. What is by 100? 0.88. So, that is X bar value, D bar value. I need D bar whole square. How much? 0.7744. This is 0.7744. Now, I'll tell you the calculation process, guys. Let's get started. So, X bar, D bar square, D square means 16. 16 into 17M plus. Next, 4 into 35M plus. The square is needed, guys. Summation FD square is needed. F into D square is what doing. Next, 28 into 0, 0. 15 into D square means 4. 15 into 4M plus. Next, 5 into 4 square means 16. 5 into 16M plus MRC. The total is 552. So, this is 552. By N is how much? by 100, no. So 552 by 100. Yes, 5.52 minus 0.7744. I got 4.746 under root. Please do apply under root. I got 2.1785, which is approximately 2.18. As you all know, D equals to x minus a. Standard deviation of D equals to standard deviation of x, as standard deviation is unaffected due to origin. Try to understand that, guys. Now let's have a look at the next MCQ. MCQ number 58. What is MCQ number 58? The sum of squares of deviations from mean of 10 observations is 250. Mean of the data is 10. Find the CV. So guys, look at this. Sum of squares of deviations from mean. So how do you denote sum of squares of deviations from mean? Sum of squares of deviations from mean for a set of 10 observations is 250. That's what my first line. And it is given that mean equals to how much? Mean equals to 10. Got it? Now, what is the formula for standard deviation, guys? Square root of summation x minus x bar whole square by n, which means 250 by 10. What is 250 by 10? 25. Root over 25, 5. So, means standard deviation equals to 5. What is the formula for CV? Standard deviation by mean into 100. No, means 5 by 10 into 100. What is 5 by 10 into 100? Your answer is 50%. So, what is your coefficient of variation, guys? 50%. So, it's all about understanding the data that is given to you and then writing the answer. Now, coming into the next MCQ, guys, there's the different MCQ. Look at 63. What will be the probable value of mean deviation when Q3 equals to 40 and Q1 equals to 15? Guys, while explaining the concept called quartile deviation, I gave you a formula for median. Do you guys remember? What is the formula for median? Q3 plus Q1 by 2. Sometimes he'll ask you to calculate the coefficient of mean deviation also. In that case, you need mean deviation and median. You can use that formula. For now, we don't need. Q3 is given and Q1 is given. No. So, what is the formula for quartile deviation, guys? Quartile deviation equals to Q3 minus Q1 by 2. Q3 minus Q1 by 2. Take your calculator and calculate Q3 minus Q1 by 2. 40 minus 15 by 2. What is 40 minus 15? 25 by 2. Forget about it. Now, guys, we have to calculate mean deviation. For that, we have 5MD equals to 6QD. Do you remember that? So, you know what is quartile deviation? 25 by 2. 25 by 2 into 6 is 75, and that is the value of 5 mean deviation. I need only mean deviation, no? So, do by 5. So, what is your mean deviation? The answer is 15, and that is there with option C. That is all about measures of dispersion, guys. So, guys, try to understand. Formulas are very essential here. And if you are able to understand the MCQs related to problems, you are in such a position to understand theory concepts. So, try to solve, try to understand the meaning of any measure of dispersion and then calculate them and then go for theory. Then only you are able to understand the concepts of the theory, guys. Okay. So, that's all about dispersion, guys.